Welcome, Malcolm. It's some years since you recorded the initial audio about the issues around using biology and chemistry for peaceful purposes, and a lot's happened since then.
A great
I'm
deal, yeah.
so it's really good that you're able to join us now and take us through where we are in this system that has changed in biotechnology and after the pandemic. So I'll hand over to you if you'd like to share your screen.
The title of my talk is Biological Security After the Pandemic, and it's mainly an attempt to talk for half an hour, 40 minutes, with the intention of surveying what the problem is, what we as an international community have been able to do about it, and then what responsibilities and possibilities there are for civil society to begin to have a bigger impact on dealing with this problem. So my talk is in 5 sections. First, a brief introduction to help set the scene that we want to talk about. And then section B on what the threat is and how it's developed over the last 100 years, and how the international community has tried to respond to that threat. Then section C is about the impact of the rapid advances in biotechnology and our understanding of the life sciences at this time, and how that complicates the problem. And then in section D, just to briefly try and say, where are we with what the states have done to develop these conventions today? And then on the back of a rather dismal assessment of where we are at that level, to ask the question and try to provide some kind of answer about what role, what better, stronger role can civil society play in trying to prevent the development and use of these kind of weapon systems. So to begin then, briefly to interrupt where we are, this data comes from May of this year. And according to the World Health Organization, about 7 million people died of COVID-19 up to that time. And in the UK, as we know, almost 220 to 6,000 people are officially said to have died from COVID. And we know that there are still large numbers of people suffering from what's called long COVID, highly variable effects on them caused by this virus. And it looks as though rather different mechanisms also. But what we need to understand, I think, is that these death numbers are almost certainly underestimates. They are what can be officially identified, but there are lots of, if you think about the normal way in which we assess the impact of these kind of pandemics, what the impact is assessed in excess deaths over the expected number of deaths. And if you use that measure, then the impact is really much higher. And certainly, whichever way you try to measure it, the impact on health, economics, society of the pandemic has been profound. It turns out that the UK actually had a biological security strategy, which it published in 2018. This year, it's updated it to 2021. And this is what's being raked over at the moment in the inquiry into how the pandemic was dealt with in this country. What I wanted to draw your attention to is that although there are different definitions of what biological security is, the UK official definition states that biological security comes from our attempts to prevent natural, accidental, or deliberate biological attacks. And these risks could affect humans, animals, or plants. Now, obviously, dealing with the possibility of natural outbreaks is important. Dealing with the possibility of accidental releases is important. And we don't know which of those actually was the cause of the outbreak of COVID-19. And both of those are also important in dealing with the possibility of a deliberate biological attack, because if you don't have good surveillance of natural outbreaks, and if you don't have good biosafety in your laboratories, then you're not going to be in much of a position to deal with something like a deliberate attack. And we have to understand that if a deliberate attack was made, it is possible that it could be far worse than the pandemic. Andy Weber, who has spent most of his career trying to help prevent the misuse of chemicals and biological agents, pointed out early in 2021 that the death rate from COVID is really quite small if you compare it with a 30% death rate that might come about from smallpox, and that somebody who deliberately bioengineered a pathogen could make it even more lethal than that. And all of this is all this danger is compounded by the fact that the advanced biotechnologies that are now becoming available could be much more widely available than previously to a lot more people. And we see that the taboo against developing and using these kinds of weapons is eroding at the present time. So this is a really important issue that we need to think about. And how do we respond? Well, first of all, I'm sure you will all know that in 1925, as a response to the massive use of chemical weapons in the First World War, the 1925 Geneva Protocol banned the use of such weapons in warfare. Less well known is the fact that biological weapons were also used against animals in that war, and the 1925 protocol also bans what was then called not biological weapons, but something similar to that. So we can say that the 1925 Geneva Protocol set the scene and the beginnings of what developed over that century in the way of a response. Here's an illustration of the kind of weapon systems that were developed in the last century. This is from John Moon's contribution on the US offensive programs in the book Deadly Cultures, Biological Weapons Since 1945. And this is an example of a number of states who went ahead and developed these kind of weapon systems in the last century. So you see the US had pathogens ready to use, such as Bacillus anthracis, which was lethal. It also had incapacitating weapons such as Coxiella, or a virus, Venezuelan equine elephantiasis, which didn't kill many people, but certainly was very incapacitating for large numbers of people. It's important also to note that toxins, i.e. not living organisms, but the poisons that they produce, were also weaponized. I think, all know that botulinum toxin is extremely lethal if presented in a way in which it gets into the system in large amounts. Staphylococcal enterotoxin B is an incapacitating toxin. It would not kill large numbers of people, but it would certainly make a large number of people ill if delivered in the right way. So here we have the Geneva Protocol, and you can see that the response to that large-scale use in the First World War was an effort by states to say this kind of thing is prohibited in the use in warfare, and that bacteriological weapons, methods of warfare, i.e. using bacteria, is also banned. So that formed the normative basis of trying to deal with this developing problem as we began to get a better understanding of these kind of pathogens and toxins and the way they affected living organisms. It took until the 1970s for a grip to be tightened on biological and toxin weapons by the agreement of the Biological and Toxins Weapons Convention, usually called the Biological Weapons Convention, but actually it clearly also covers toxins. And this is what is called the general purpose criterion set out, in the sense that you can do anything for peaceful purposes, but the Geneva Protocol says you can't use these things as weapons of war. And here the state parties also undertake never in any circumstances to develop, produce, stockpile, otherwise occur or retain microbial or other biological agents or toxins for other than peaceful purposes. So it's a sweeping ban, but it's a ban in a very early modern arms control agreement. It's not very long in terms of the text, and it's still without a major international organization to handle its development and operation. In the 1990s, by that time, many states had developed large amounts of chemical weapons, particularly lethal chemical weapons like nerve agents. And the Chemical Weapons Convention came about at the end of the Cold War in unusual circumstances where it was possible to move towards a really significant major modern convention, which again, as you can see, has the similar kind of general purpose criterion that we have in the Biological Weapons Convention, but much more definitively pinned down. So again, you can see prohibits the development, production, acquisition, stockpiling, retention, or transfer or use of chemical weapons, defined as toxic chemicals and their precursors, except were intended for purposes not prohibited under the convention, and as long as the types and quantities are consistent with such peaceful purposes. And a toxic chemical means any chemical which through its chemical action on life processes can cause death, temporary incapacitation, or permanent harm to humans or animals. What happens then is that the initial stage of the conventions operations had to deal with the problem of these huge stocks of lethal chemical weapons which had accumulated. And therefore, it required a major international organization, which is located in The Hague, and it required the kinds of chemicals that were of concern to be specified in schedules, and that those schedules then allowed the verification of the destruction of all those munitions, and for which the Chemical Weapons Convention received the 2015 Nobel Peace Prize. And in September of this year, the final declared chemical weapons amongst the state parties will be destroyed in the United States. There's a complication that we need just to note here, in that, as the World Health Organization pointed out in 2004, in the sense of these conventions, toxins does not have the same meaning as scientists would use. Because whereas scientists might see a bioregulator, one of the chemicals which is used in our bodies to regulate our activities, the treaty would see it as a poisonous substance produced by a living organism if it was administered in a different kind of way, in a large quantity, for instance. And that the convention would see that as a toxin. And as the World Health Organization went on to explain, clearly histamine is a major component of wasp venom, but it's also a human bioregulator. And just in case people like me get stung by a wasp, we have to carry around with us during the summer period 2 EpiPens so that we can make sure that we don't have a really bad response to this natural bioregulator chemical injected into us in an unusual way. So what we can say in summary then is that the biochemical threat spectrum consists of, in the columns, classical chemical weapons like nerve agents, industrial chemicals such as the fentanyl, which was used to make people unconscious in order to deal with the 2002 Moscow theater siege, natural bioregulatory peptides, toxins, and then coming in from the other side, traditional biological weapons like anthrax or plague or tularemia, and genetically modified or tailored agents where the modern technologies are used to modify the traditional agents. So that's the threat spectrum. And then you can see down at the bottom here that the Chemical Weapons Convention covers chemicals through to both bioregulators and toxins. And the Biological Weapons Convention, coming in from the other side, covers traditional biological weapons, genetically modified biological weapons, toxins, and bioregulators. So in a sense, we should have a comprehensive coverage of this threat in the conventions, and particularly in the middle, where there is real possibility of erosion by the use of these toxins or bioregulators at the present time, there should be double coverage. So we should basically be really quite well covered in dealing with these agents. However, anyone who watches the news at the present time knows that there are continual new breakthroughs in biotechnology and the life sciences. And these are all to the good. I don't know if you noticed recently that in the States, our first chemical agent has been approved for helping people with Alzheimer's, and it seems that this has the impact of probably slowing down the decline in Alzheimer's disease by about a quarter. Obviously, we all want those kind of beneficial things to be achieved by our life scientists. But we have to be careful that we understand that what's going on, which was pointed out by Professor Matt Meselson from Harvard 25 years ago almost, that what we're doing is understanding life processes, fundamentalized processes, well enough, not only for malign purposes to destroy life, but also to be able to manipulate it. And manipulating cognition, development, reproduction, inheritance, becoming more and more possible. And as Matt pointed out, therein could lie unprecedented opportunities for violence, coercion, repression, or subjugation. Round about the same time as well, three military analysts in the United States specifically pointed out what this kind of advance in our understanding would mean in terms of possible development of new weapon systems. Most of the last century's weapons agents in this area came about because a natural bacterium, say like anthrax, was known to be deadly, and by working on it, working out how it worked, modifying it so that it could be spread more easily in a weapon system and so on. That's the way that those kind of agents came about. But what Petro and his colleagues pointed out was because of our advancing knowledge, future biological agents could be rationally engineered to target a wide variety of specific human biological systems at the molecular level. And if you think about that, if that got out of hand, then the number of different weapons agents that could be developed would rapidly multiply, and defense against them would become more and more difficult as more and more things had to be thought about and worked out how to deal with an attack with that kind of agent. So in combination then, what the impact is of this developing biotechnology is not only, of course, the good things that come, but if we're not careful, a raft of things which we don't really want to happen. And Julian Perry Robinson, again, some time ago, noted that what is different about chemical and biological weapons is that whilst they could be used as weapons of mass destruction, and that would be dreadful, but what's really unique about them is that they could, at least in principle, be used for a whole variety of other malign purposes. Even very large numbers of people could be threatened without necessarily threatening their lives. And as Julian pointed out at the time, the capability for using that kind of force could be very attractive for certain people with malign intentions. So we're not just dealing here with a weapon of mass destruction. We're dealing with weapon systems that could be deployed in a huge variety of ways. Think about the way in which in Syria, chemical weapons were used basically to clear people out of the places they live. Or think about the way that nerve agents have been used in assassination attempts in Malaysia, in the UK, and elsewhere. So where are we now with dealing with this problem? The United Nations Institute for Disarmament Research back in 2022 set out a limited range of possible outcomes of the review conference in December of last year that I mentioned at the beginning. Now, you have to understand that the Biological Weapons Convention has been basically in stalemate through this century. An attempt was made to toughen it up during the 1990s, and that failed. And what we've had since is annual meetings of experts and states parties trying to find ways of getting around the fact that they couldn't agree a verification system and seeing if there are other things they could do that might help. One of the outcomes that UNIDIR suggested was exactly a continuation of that process. And as it pointed out, this approach has diminishing value to all concerned. It's a bit more complicated than that, but basically that's the outcome from that review conference in December. You might say not too surprising given the ongoing war in Ukraine. The Chemical Weapons Convention, of course, is much stronger in form and in institution than the Biological Weapons Convention. And again, UNIDIR earlier this year had an assessment of where that review conference in May might result. And again, there were a range of possibilities put forward. And the worst of those possibilities was that they couldn't agree anything significant and implementable. And as in the previous review conference in 2018, all that could be done was the chairman to produce a report talking through what had been talked about. And again, that was essentially what resulted from the review conference. So, in summary of the current situation, the Biological and Toxin Weapons Convention is weak. It only has a small organization in Geneva and inadequate verification. There's been stalemate since the failure to negotiate a verification system in the 1990s. And although there were some hopeful steps forward, despite the difficulties in December, anyone looking realistically at the situation would say progress in dealing with the biotechnology revolution and its impact on the Biological and Toxin Weapons Convention is likely to remain slow and difficult. In regard to the Chemical Weapons Convention, it's much stronger, of course, than the Biological and Toxin Weapons Convention. It has a large organization in The Hague and a good verification system which has been used for the destruction of the 20th century chemical weapons. However, it's had difficulties in trying to deal with issues such as use of chemical weapons in Syria and efforts to prevent the use of chemicals which attack the central nervous system being used for so-called law enforcement operations. And they've had to resort to majority voting rather than consensus in dealing with these kind of issues. So the Chemical Weapons Convention has ability to carry out the functions of destruction, but destruction phase is almost over. But it's likely again that will be slow progress, difficult progress in dealing with the impact of the biotechnology revolution. So that then leaves us to the question of what kind of things might be possible for civil society to bring to bear to help deal with this problem. And we don't need to start from scratch, because since the early 1990s, there's been the evolution of the idea of a web of deterrence, as it was called in the beginning, but eventually now called a web of prevention, which argues that the conventions are the central strands, but around them, there's a lot of other things that can be done to help to ensure that these kind of advances in biotechnologies are not misused. And you can think then of the conceptual framework of international biosafety and biosecurity standards, export controls, guidelines on what kinds of things and what kind of oversight there should be in terms of what can be undertaken. For example, should very dangerous experiments be carried out without proper, very high levels of biological containment systems in place? And this range of policies in the web of prevention surely includes the development of codes of conduct for scientists related to the Biological Weapons Convention and the Chemical Weapons Convention. And there is a huge problem there, which was pointed out last year by the World Health Organization in its attempt to develop a global guidance framework for the responsible use of life sciences, managing biorisks and governing dual-use research. Dual-use research is research which, although carried out for beneficial reasons, might produce knowledge or technologies or materials that could then be subject to malign misuse by others. And what the WHO found, and this merely said the same thing, but in a more systematic way than had been shown in many other reports over the last couple of decades, there's a chronic and fundamental challenge in this biorisk management, is that there's a widespread lack of awareness amongst the scientific community that their work could be conducted or misused in ways that result in health and security risks to the public. And this lack of awareness is not surprising, because their education rarely covers this particular issue, and their on-the-job training also rarely covers this issue of the possible deliberate misuse of their work. And obviously, if they're unaware of this potential misuse, then they can't really accurately weigh the risks and benefits of the research that they propose to carry out. It's for this reason that you begin to see within the conventions the development of ethical guidelines for use in codes of conduct for chemists. In particular, in 2015, besides receiving the Nobel Peace Prize, the Chemical Weapons Convention organization was instrumental also in the development of the Hague Ethical Guidelines for Chemists. And these elements of the guidelines are awareness and engagement, sustainability, ethics, education, safety and security. And the implementation of the attempt to get these guidelines followed by chemists around the world was supported by the Organization for the Prohibition of Chemical Weapons, developing also an advisory board for education and outreach to assist in the development and implementation of education and outreach to scientists, which is relevant to the Chemical Weapons Convention. And it's busy developing a portfolio of activities along those lines. Later, the state parties to the, some of the state parties to the Biological and Weapons Convention decided that something like that was also necessary for life scientists. And in particular, the Chinese and the Americans did a lot of combined work, financed combined work by their scientists to develop these Tianjin ethical guidelines for life scientists. And these guidelines were endorsed by the Inter-Academy Panel of National Scientific Academies and presented to the state parties to the Biological Weapons Convention in July 2021. And these guidelines build on the guidelines in the Hague system. There are more of them. They're more complex in what they state. And what I just want to focus on in the little time I've got left is on the education and training aspect. Because without the education and training being implemented, then it's hard to see, as the WHO pointed out, seeing the codes of conduct being implemented. So element 6 of the Tianjin guidelines says scientists, along with their professional associations in industry and academia, should work to maintain a well-educated, fully trained scientific community that is well versed in relevant laws, regulations, international obligations, and norms. And that the education should encompass multiple fields, not just the science, but social and human sciences and ethics. And this ethical training should be given on a regular basis. So if this kind of thing could become widespread, widely understood, widely implemented, you could see that civil society would be in a much stronger position to enable pressure to be put on state parties to do something about strengthening these conventions. Let me just make sure we're, yep, okay. So where are we in terms of biosecurity education? We did a survey of all the educational projects we could find which have been carried out over the last 20 odd years. And we came to, first of all, a quite optimistic view that most of the educational activities were carried out by academic life scientists. So there's probably a good cohort of scientists around the world who know how to set up these activities and can assist in new ventures. Moreover, the projects were carried out in a very wide range of different countries, and so the expertise is not sort of narrowly focused, but is quite widely spread in different countries around the world. So that was an optimistic outcome. But there were also problems. First problem is that the original language used in most of these projects was English, and very few involved making translations of the material used, even into the 6 official UN languages. So this is a problem that would have to be addressed if the kind of needed progress is to be achieved. And really, when you looked at the large numbers of projects, they were usually small scale, were not sustainable, and very often were not very innovative in the methods that they were used. So there was obviously a need for big scale up in the educational activities needed to implement the Tianjin guidelines. But some of these problems are solvable. For instance, we were involved in the development of a set of cartoons, 5 cartoons, each involving 2 pages like this and several lines of picture to tell a story. But because it was a cartoon, the amount of text needed was really quite small, and therefore it was possible to translate all of the text with a bit of fiddling. All of the text could be translated into all 6 official UN languages, and additionally into another 6 languages as well. And this did not require payment of large fees for translation, because it could usually be done by scientists who were involved in this issue in their own country and in their own language. In fact, it was much better done with them because they understood the nuances of the different language uses in the, for instance, biosecurity can have different meanings in different languages, and therefore the scientists who were translating into their own language could make sure that that was the meaning was understood in that language and context. There's obviously also a need for a resource book to underpin efforts to develop educational material to supplement life science courses in upper schools and in universities. And there is at the present time a book with 20 chapters in the final stages of production. The final chapters are due in at the beginning of August, and this will be published next year by Wiley. So each of these sections has multiple chapters. All of the chapters have a similar framework. All of them are fairly short, with a small number of key references, and it's all designed to be easily assimilated by a lecturer or a teacher who wants to add some of this material to their own courses. And it's also being designed as far as possible to minimize the amount of costs in making translations. And finally, just to say that when this lecture was being put together and put to bed, the World Health Organization put out a call for a consultant to work on WH training on responsible use of the life sciences and dual use research, i.e. to begin to produce education to supplement their global framework. The external consultant was required for 6 months and would be required to contribute to the development of an online training course on responsible use of the life sciences and dual use research. And the deliverable, development of the draft content of the training course, was expected by the end of August 2023. So it's nice to end this presentation on an optimistic note that it's not just civil society, but now also major international organization with responsibilities in this area, beginning to push hard to get something done. So with that, Jeff, I will close and just add that if anyone really has a question about some aspect of this, if you could send your question to Jeff and he'll make sure you understand where it has to go, I will certainly be very happy to try to answer the questions. Thanks.
Okay, well, do you want to stop sharing your screen? Because I've got a question before we go.
Okay, sharing Sheen. Stop.
As you know, this is going on the Food Systems Academy website, and it is already you're not supposed to use food as a weapon, but from what you've said, the agricultural sciences and the role of biotechnology could mean it would be much easier to make very targeted use on particular crops or animals in different parts of the world of these kind of biological and toxin agents. Is there any evidence that work is A, happening on that, or B, that people are aware and they're trying to avoid that?
Well, what you have to say is, although there's a huge amount of information available about the offensive programs of the last century, this information is not widely understood. And you can be sure that in the offensive programs, it wasn't only human beings that were the potential targets. Considerable efforts were made to understand how to deal with really important essential crops like rice or wheat, or to attack significant economic crops in particular parts of the world. And remember, back in the First World War, the original biological warfare was against horses because they were so important as draft animals. And certainly there were efforts also to think about how you would attack particularly important animal stocks. To give you an example, foot and mouth disease. I mean, it's obvious that from what we know that natural outbreaks or accidental outbreaks of foot and mouth disease have dramatic effects on not just the animals, but the economic system, which is devoted to producing those animals. Earlier this century, the foot and mouth disease in the UK had a devastating effect.
Well, thank you very much, Malcolm. If we're both around to review this for 2030, say, I hope we can see some more positive developments, and some of these conventions have been toughened up and actually used despite what we see going on in the world. And thank you very much.
Thank you, Jack.